Welcome back. So what we're going to look at today is we're going to look at water, and we're specifically going to look at sewage treatment. So our learning intentions are to describe the processes involved in sewage treatment. So we're going to start by looking at sewage treatment, and sewage is material delivered to waste treatment plants of towns and cities. So sewage could simply be classified as used water, domestic waste, discharges from commercial establishments are examples of sewage. Sewage and waste material usually has a high biochemical oxygen demand and usually contains lots of nitrates and phosphates. So it needs to be treated before it passes into the river or the sea to prevent pollution by eutrophication or heavy metals. There's three main stages that we're going to look at. Primary treatment, which is physical stage, secondary treatment, which is the biological stage, and tertiary treatment, which is the chemical stage. So for primary treatment, we'll start with the definition. It's a mechanical process in which large solids are removed by screening and some suspended solids are removed by settlement. So primary treatment involves mainly screening and settlement. It's referred to as the physical stage, and the incoming sewage is screened to remove large debris and non-biodegradable material. It passes into large settlement or sedimentation tanks, and in these tanks about 50% of the suspended solids are removed and about 30% of the biochemical oxygen demand is removed. The liquid at the top of these settlement tanks is then passed on to the secondary treatment stage. So our definition for secondary treatment: it's biological oxidation in which the levels of suspended and dissolved organic materials are reduced. The secondary treatment stage, as the definition says, is the biological stage. The incoming sewage from the first stage of treatment is passed through aeration tanks, where mechanical stirrers aerate it. This allows for aerobic bacteria and other microorganisms to break down the solid matter into a harmless sludge called activated sludge, and that's a key word that should be included always in these questions. The third stage then, the sewage then flows into settling tanks, and the sludge can be reused or recycled to make methane, and at this point 95% of the biochemical oxygen demand has been removed. The final stage of sewage treatment is the tertiary treatment, and the definition is a process that involves the removal of phosphorus compounds by precipitation and nitrogen compounds by biological and ion exchange. Tertiary treatment is commonly referred to as the chemical stage, and basically when the liquid comes from the secondary treatment, it is clean and inoffensive, but it does contain compounds of nitrates and phosphates, and we want to remove those in this stage. So the phosphates come from washing powders or washing up liquids, and the nitrates tend to come from organic material in sewage. These nitrates and phosphates must be removed before the water is discharged into the river, as it could cause eutrophication. The phosphates can be removed by adding aluminium sulfate, and that will cause aluminium phosphate to precipitate out. Another possibility is adding iron 3 chloride, causing iron 3 phosphate to precipitate out. Lime can also be used. Insoluble phosphate compounds are then allowed to settle out before discharge into the waterways. Nitrate removal can be quite expensive, and nitrates are removed using denitrifying bacteria, which convert nitrogen ions to nitrogen gas. As I've said, it's difficult and expensive, as nitrogen may be present in many forms. So that's it for this video. Make sure to revisit the learning intentions to make sure you understand everything that we've gone through.